Good evening everybody, and once again welcome back to the channel. In today's video I want to talk about universal data lake syncing table formats reference architecture. So in this particular reference architecture that I will show you is we have some sort of table formats on data lake, either Hudi, Iceberg or Delta, doesn't really matter. The goal is I want to build the metadata for all the three table formats. Now, why would you want to do that? Because it's a universal table, meaning I can easily access the table into Iceberg ecosystem or Hudi ecosystem or Databricks ecosystem, right? They all work fine, right? You don't have to worry about whether I choose Hudi or whether I choose Iceberg or whether I use Delta. You can interoperate between all the three formats. This architecture uses Apache XTable on AWS Lambda function. You can schedule the sync. You can schedule the sync of a Lambda function, which is going to execute the XTable sync command through an event bridge. So you can do this on an hourly or a daily schedule, however you like. But you also have the ability to fire this Lambda function through an API, either Flask API or a Fast API or API gateway, or you can invoke this in a process-driven manner as well, right? So you have the flexibility to do that. The Lambda function is quite generic. All it does, it takes the path to the config file and then it downloads the config file in the local temp directory, executes the Apache XTable sync commands, which builds the metadata for Iceberg, Delta, and Hudi, and then it does the cleanup, right? So hopefully this made sense. And now we're gonna do a hands-on lab. All right, so it's time we do a hands-on lab. So first of all, we'll be using this particular GitHub repository, XTable sync Lambda. Make sure to give a star if you believe I've done a good job. So first, let's copy the URL, and then we're gonna do git clone the repo name, and then we're gonna cd into that. So make sure you do the step one, which is clone the particular repository. All right, so the next step is we need some table to play with, and I will give you this sample Hudi table. If you observe on my computer, in my directory, I have a folder called people, and there is some folders and some Hudi folder which contains the metadata. So what I want you to do is go to S3, create whatever directory you like. I'm gonna use this S3 bucket, data lake demo 1995, and then I have a folder called Hudi. There's no table inside here. I will come here, I will drag these files here, okay, and then click on upload. So this will create a Hudi table on my S3. Okay, so here you can see I have .hudi folder and then all the Hive style partition and the Parquet files. So again, if you want to try this on your own Hudi table, feel free. But if you do not have a Hudi table, you can use this demo table for now. Okay. All right, so now the step 3 in the process is go to the Docker file and edit your AWS access, secret, and region. This should be on line number 21. I've already put my access secret keys, so I don't want to show them to you, of course. So make sure you put these access keys in the Docker file, okay? Once you're done with this part, now we're gonna go to the next part, okay? So now you will see a README page over here, which of course has all the commands listed here, or you can go to the GitHub page and probably read everything, right? So assuming you have done that, now we will have a config.yml file. So I'm gonna create this file in the directory, config.yml, okay, as you can see, and then I'm gonna copy the contents here. And then again, paste your path to the Hudi table, right? In my case, the Hudi table was inside the folder called, as you can see, Hudi. So I'm gonna copy that and I will paste this one over here. Once this is done, now we need to push this config file on S3. So I'm gonna copy this command, try to use my notes here quickly. So now I will do AWS S3 CP. So the path to your local path and then the S3 path, right? So let me copy that, okay? And let me create, okay, so I'm gonna copy that. And then over here, my path is over here. So I'm gonna do copy. I replace that over here, okay? And then on S3, wherever you wanna dump that particular file, right? So I would probably do it in this particular folder. So I would say, hey, you know what? Dump this inside a config folder and the file name will be config.yml. I'll delete this from S3. So when I do the copy command, you will see that file has been created. So just deleting that file. Okay, cool. All right, so I will copy that, go to my terminal, paste this one here, and here you can see the upload has been complete. So now if I refresh here, I have a config file. So now when we fire the Lambda function, we'll provide the path to this, and the Lambda function will download it in the local directory and then execute the sync command. So now let's take a look at that process. All right, so the next step here is I will copy this command. So I'm going to build the Docker image. So let's say we are in the current directory, right? Now simply issue a command, docker build -t, docker build -t. We're going to name the image XTable Lambda, and dot means look for the Docker file in the current working directory. This will take a little time because he has to like build the image. So let me pause the video, and once the Docker build is complete, I will show you the next part. All right, so looks like my image build has now completed. And now what I am doing is I am gonna run the Lambda function locally. Again, you can create an ECR with an repo name, and then you can push the Docker image there, and then you can link that on the Lambda function. It's gonna work absolutely fine. In fact, I will actually update the GitHub with the infrastructure code. So when you want to deploy to production, you just say SLS deploy, boom, everything takes care, right? But for now, let's just see if it works locally, right? So now I'm gonna run the Docker image. Okay, so I come here, I'm running. So now my Lambda function is running on a Docker container, as you can see. Now I would fire the Lambda function with this command over here, curl command, as you can see. If I can copy that, probably. All right, okay, cool. Let's see if I can. Before that, I want to show you here, I don't have any metadata folder for Iceberg or Delta, right? Just want to make sure I show you that, okay? All right. Let's see if I have curl installed. Hopefully I do. So I'm gonna fire the command, and if you observe, look, the sync process has started. The Lambda function is now executing, and it's building the metadata for Iceberg and Delta, right? So I am right now on my S3. If I go to my console, I'm assuming it is still running probably. Yes, it succeeded, as you can see. A little hard to see because of the font size, but let's go to S3 and see if it worked, right? So if I refresh, as you can see over here, I have the metadata folder, and it was able to build the Iceberg metadata for it, right? So hopefully made sense, right? Here you can add Delta also, and it will build the metadata for Delta, right? So you see how modular this is. It takes care of everything, right? All you do is just put an S3 path to the config file. The Lambda function downloads it and then executes a sync command. I just want to show you the code really quickly in case if you're interested, of course. But Lambda function right here. I use a library called jpyp, right? That's the one that I use to invoke the Java class. So actually very easy if you see the code, right? Over here, try catch, of course, you want to have a try catch always in the code. Takes the path. So through the event, you provide the path. If the path is not there, I raise an exception. If the path is there, then it downloads the config in the local directory. You can see I have a function download config. Once the download is complete, as you can see, right, we write that into the local file system on the Lambda function, and then we read it. We read the config file. After reading, I basically create a jpyp j class for or.apache.xtable.utilities.run sync. And then guess what? Just I call run sync.main. I provide the data config and the path to that particular one, and then it builds some metadata for you. Now you can schedule this on an event bridge. It can run on a cron. It can do that. You can fire it whenever you want through an API, or you can bake it into some process. So whenever your process is completed, it invokes the Lambda function asynchronously, and it will build the metadata for all the three table formats, right? So I hope you enjoyed. I hope you enjoyed the video, of course. And that being said, I'll definitely make sure. I mean, the infrastructure code is not. It's like just few lines of code. I'll probably complete that over the weekends. And but that being said, check the solution out. And again, Lambda being serverless, it can easily scale up or down based on how many tables you're doing, right? So thank you so much for watching the video. And by the way, before I say goodbye, I do want to comment out on, I have a blog and I've included all the steps over here. So check it out. All the materials and explanation is there on my blog as well. With that being said, thank you so very much for watching the video. I hope you enjoyed, and I'm excited that this solution will be deployed in your AWS account. And now you're gonna run sync command for all the 3 table formats, and consume your Hudi tables into Iceberg ecosystem, or Iceberg tables into Hudi ecosystem, or Hudi tables into Databricks ecosystem, vice versa, right? Thank you so much, and I will see you in the next video.